Okay, so I'm going to go to the libxor library. Okay, so I'm just going to minimize this. Okay, so I have created an example 17, which we're calling textures. I'm not using that anymore. Okay, so in this, might as well just show you how I'm loading this up. But we have our we have a texture map here called testtexture.png. We have a picture, a low-res picture of Godzilla, a parrot picture. Parrot's kind of a popular image for testing things out with. And then I'm adding a frame buffer object that I'm calling gbuffer. So we're loading a few texture maps. We're creating an FBO that we're going to be able to render to. And just to kind of, we have 3 render configurations that I'm setting up. The first render configuration is to draw the gbuffer, and I'm just using basic.vert and gbuffer.frag. And we're saying use the depth test. We're adding a texture. So this, in the render configuration, I added a method to be able to reference one of these texture maps that we're loading. So test2d is testtexture.png. And map.kd is inside the shader. That's what we want to use. That's the uniform that we want that texture to do. And the reason we're doing this is so that we can easily just say, load this texture map and use it on this uniform. So it's a way of doing some simple material stuff. In this one, we have a flag, a string called write to FBO. So we can say use gbuffer. Okay. The second render configuration is just we're going to use that to render just a simple rectangle or square in the middle of the screen with a texture so we can try out different parameters. And we're going to use the Godzilla texture because he's low resolution, but we'll probably switch up between the parrots so we can see different things. And then the last one is a render to texture render configuration that will then read from the gbuffer and draw that on the screen. And I also have we'll use the test2d texture in that shader as well. Then we're loading the Mitsuba object and the rectangle object, which is just a simple square that goes from -1 to +1 on the X and Y. And then full screen quad is going to be a rectangle that goes from 0, 0 to width and height. So we're going to draw a rectangle on a screen that we want to fill the whole screen with. Okay, so inside the update function, we just check to see if we hit the space key, and we just turn a flag off to say whether or not we're using the render to texture feature. Any questions so far on the initialization? We're just kind of pulling in some resources. Now we're going to do something with it. Okay. Just close some of the stuff that I don't need open. Okay, so okay, so let's look at the render. So I have 3 parts. The first part is if I want to render to texture. So we'll talk about that in just a bit. The second part over here, I'm actually rendering with the default shader. So that's just that's gonna be the rectangle in the middle of the screen. And then lastly, we're going to draw the we're going to use the render to texture shader, which is like the gbuffer kind of algorithm. But you'll notice in here that I'm scaling that rectangle by half. In other words, it's going to fit in a quarter of the screen, just for so we'll see that in just a bit. Okay, so let's go ahead and look at this in action. Wrong one. Okay, so you'll see we got the Godzilla texture map over here, and what's the thing that you noticed that I said was going to be apparent? What's that? The texture map. So we're using it's upside down, right? Because that makes sense because the bitmap starts here and the origin is over here for the other. Okay, so we have to fix that, right? We got to fix that. So let's go to our shader program, and this is just to help you recognize patterns. We don't, I like to fix that inside the vertex shader. So we're going to take the S coordinate. We're going to go 1 minus. Why are we going to do 1 minus? What's that? Because if we do 1 minus anything, right? And this is a useful trick. If you have a flag that you want to go between 0 and 1, just go 1 minus the thing. But let's just use 0.7 because that's kind of I guess a good way to. It's a nice. You don't want to go 1 minus 1/2 because then it's just 1/2, right? But if we do 1 minus 0.7, then we get 0.3. Okay, so in other words, if this is the top half of the image, right? So if we do 1 minus 0.7, we really want this one, right? But that means that the image, we have to go down 0.3 in order to get to that element. Okay. Now we don't want to do, because sometimes you're like, if you just like brainstorming, how can I quickly flip this image upside down? You might think, well, let's just take minus the coordinate. That might be a simplistic way. Okay, so let's see if that works. See, it does work. Okay, it does work. Now, this is why we have to be careful. Okay, because we're gonna play around with some things. We have minus 0.7, and we want to go down 0.7. So what's going to end up happening is that because we're mapping this backwards, we're going to be reading. Well, technically, yeah, we're going to be reading because. Remember, we're doing repeat, right? But if we had minus 0.01, then that's going to start reading into 0.99. Because negative numbers are handled a little differently, so that we're repeating the correct way. Okay? So the reason why is because the image is already backwards. So if we're looking down here and the image is already backwards, then we are technically going up to this point. Okay, so where this is a problem is it's not accurate to say. I mean, theoretically, it solved the problem, right? But it doesn't work because if you switch your texture mode to repeat or clamp, what's going to happen with minus 0.7? If we set it to clamp. Minus 0.7 is going to get clamped to what value? 0. And now what pixels are you reading? you're reading like the bottom left corner and you're going to get a solid color because it's not accurate. Okay, so sometimes you'll, this looks like it could be plausible because now we're reading the image backwards. So now we're reading it the correct way, but we want 1.0 because this is going to make our texture coordinates correct for this situation. Okay, so this is just to highlight that sometimes you can do things the wrong way and still get right results. But it's not foolproof because then you might have another case where you're reading the wrong coordinates and you have it set to clamp and you're like, how come I'm getting a solid color? Solid color normally tells you you're not using a texture map, and then you're going to be chasing your tail, looking for a bug that really is just a very subtle bug. Okay, so or the other thing you'll do is you'll do 1 minus the whole thing. 1 minus. This is another bug. This is even harder to catch. Why is this harder to catch? Is it? It looks like it's working. Let's do another. Let's switch that texture map that we're using. I'm gonna instead of Godzilla, I'm gonna use Test 2D. Okay. Do you see a problem? Look at the numbers. Now we're flipped horizontally. So by taking 1 minus the texture coordinate, yeah, we fixed the problem of it being the vertical part, but we also flipped the texture map around, and now all the textures are like, why? That's another subtle bug that's hard to catch because you're like, well, I'm doing 1 minus. That's the correct way, right? But it doesn't work because if it's backwards, then it won't look right. Okay, so those are, let's go back to Godzilla and go back here. Okay, so like I said, this is a very subtle thing. Oh, I'm doing 1 minus 0. I'm doing 1 minus. That should work. But the correct thing is we need to correct the coordinates. So it's S and 1 minus. Now, another way to fix the problem is that when you read in your textures, make sure you flip the texture before you upload it to begin with so that the origin's on the bottom. So as you're reading every line of the image, put those in, stack them bottom up. Okay, so in other words, as I'm reading this in line by line, I'll put this one technically on the very bottom of my new frame buffer. This one, and stacking them up in reverse order. Okay, just like a stack of blocks, right? Get your stack of blocks, take one down, put it over here, take it off, and eventually you have flipped your stack of blocks, and now it's correct. So that's the other way to fix it, is just say, I'm not going to be dealing with this in a shader program. I'm going to just fix it by making sure that all my textures are loaded up correctly. This works, I guess, if you're making middleware and you want to make sure that when somebody uploads an image, they don't get confused with all this. Like, how come my textures are upside down? All right. Those are all design choices. Okay. I like, because this is teaching, I'd rather just show you what you input's what you get. So we have to fix it. So here's another good thing for vertex shaders to fix your texture coordinates. Okay. Now, we will notice one thing, and that is what's happening to this texture map. Thinking about the size of the texture map. But what's happening? Yeah, we got these square looking pixels, right? Because the size of the texture map is too small too small compared to the size of the rectangle we're trying to draw on. You can get the opposite problem too, where the texture is too big for the size of the triangle, and then as you get smaller, then you're struggling to figure out, well, which pixels am I supposed to use? Okay, because you're trying to squeeze this much data into one pixel, and now it's like, well, which one do I pick? So you have two problems. One's magnification. The other one is called minification. When you make it smaller or when you make it larger. Let's play around with this. So inside, well, I don't know if I have. Normally we're inside texture 0, which is what this one is. So I'm going to just play with the texture parameter. And let's go ahead and first let's play with the wrapping so we can see what happens. So I'm going to go to my rectangle object, and we're going to get this so that it wraps around 4 times. Okay, so hey, there we go. We can tile it across the image or across the texture map. Now, so that works. That's not too bad. But what if we didn't want that? What if we wanted to clamp it to the edge? Okay, so that's another option. So let's change let's change to clamp to edge on the S coordinate, which is the Does that work? Let's make sure we're actually using the I'm curious why that's not. Oh. Wrong section. Okay. I still wanted to do repeat on this one. Okay, should work now. Now we're doing something else wrong. Let's probably set active textures. Trying to get the WebGL rendering context. There we go. Okay, so now we're clamping to the edge when it comes to the S coordinate, right? So now we can kind of go back and, you know, make sure that we don't go past our original point here. But we have one little issue is we can't see all the details going on, right? Because the picture is surrounded by white. So I'm gonna quickly just turn this to the test texture. That way we can see what happens. Like, what is getting clamped to the edge? So you'll see that it's actually pulling whatever that value is. So over here, white is the I'm trying to look here. Yeah, white is the, so whatever the checkerboard pattern is over there. It looks strange. It looks strange, but it's not really. Let me zoom in real quick so we can have a good view. Okay, it looks strange, but it's not. In other words, you might thinking, is it really wrapping around? But that's supposed to be white. That's supposed to be black, and then those checker patterns are basically being pulled off to the side. So now let's change it so that, oops. Both are clamped to edge, and then we'll show you. I'll show you mirrored repeat. Okay, so there's if we clamp to edge on the vertical. So sometimes you don't want it to go past that point, and this is what's going to happen. So if you were trying to tile an image and you saw this pattern, what do you think you need to change? You want to tile the image on the polygon. So what do you need to change to do that? Well, first of all, what pattern does this tell you? Which repeat mode is being used? Right, clamp, right? Because anytime we go outside the values, we clamp it to the edge of the image. In other words, if I'm over here and I go past this point a little bit, we're saying that we don't go past 1. So then 1 is white. That's what sample it is. So we'll see white go on forever in this direction. And over here, if we're trying to go past 1, we'll see white go on forever in this direction. Over here, if we're going less than 0, we'll see black go on forever in this direction. If we're going less than or greater than 1 on this direction, we'll see black continue, and that's exactly what you see over here. So which pattern are we seeing in this image? Which repeat mode are we using? Clamp. We're using clamp. So what if we want to tile the image? What if we want to tile this image across this polygon and not have it clamped? Which mode do we use? Repeat. Okay. So we use repeat, and that'll get us what we want. Okay, so we turn it to repeat. And now we can see that our image is now got the nice repeat. Now, do you see all this like sparkling business going on? Okay. This is what I'm talking about. Now the texture map is too small or too large. The texture map is too large. We're trying to draw it in a smaller space. It just doesn't know which pixel it should pick. We're going to fix that in just a bit, but I did want to show you mirrored repeat. Now, what do you think mirrored repeat is going to do? What do you think mirrored repeat is going to do to this, to our texture? Yeah, so here's mirrored repeat. In other words, we're gonna, as we're moving in this direction, we get over here, okay, let's go back this way, then let's go back this way, then let's let's go back this way. Let's go back this way. And so we basically just change the direction. Now, why would mirrored repeat be useful?
Geometric patterns.
Okay, geometric patterns. What else? What if your texture doesn't tile? What happens if you have an image like this? Right? Does that tile?
Not very nicely.
Not very nicely, but what happens if you do mirrored repeat?
All
Yeah, it all matches. So just like if you're going to Lowe's or Home Depot and you're like, I'm gonna put some nice tile on the bathroom floor, or in the shower, you go buy yourself some tile and you're like, oh, they don't really tile very nicely. What can you do? You can just kind of rotate them, and now you can get them to tile. Okay, so if you have texture maps and you didn't tile them, then this is one way you can do that. Okay, so there's mirrored repeat. Now let's go ahead and fix this issue of these polygons, or these, look at this. This is just, oh, look at that. Oh my gosh, this is gonna sell your AAA title right there. That's people love to see that kind of stuff. Okay, let's work on that part. So the first thing we could do is we can use, let's change the minification mode. And the first one we're gonna try, because the default is nearest. Nearest means whatever the closest pixel I can find for this floating point number, that's the one we're grabbing. Okay, doesn't matter if it's completely different the next time. So one way of doing this is to use a mipmap. Now, does anybody know what mipmapping is? Mipmapping is where you take your image and you apply a filter to it so that you create a smaller image that's 2 by 2. Wait, okay, so this is level 0. This is level 1. Okay, so what you do then is and sadly what happens at this point is the simplest way is just to add all of them up, is to take the average. So what's the average of white and black? A nice solid gray. Okay. And what's the average of white and black? Nice solid gray. Okay, sadly this is what happens. Okay. However, if you happen to have and then the next level is, then we take this 2 by 2 and turn it into a 1 by 1. Okay. Which also gray averaged together is great. However, if you have bigger texture maps, right? If you start with a 256 by 256 map, then you can take that. Okay. Let's say it's 256 by 256, right? Then you can turn it into a smaller 128 by 128, and so on and so forth. And then what will happen is that we can use OpenGL to decide, well, the best texture map for this minification level is then it picks the correct level. So let's take a look at this. Okay, perfect. So you'll notice that in this case, we are getting that pixelation we saw in the Godzilla image, right? Because the parrot texture is a larger texture map. We have a lot more detail. However, you can see that as we created the smaller levels, it still looks like a parrot, So for the most part, you don't have to worry about this issue too much. But let's see what happens, though, when we decide to cross this corner. You see that the lower units are getting picked. Did you notice that? We're picking the lower and lower resolution textures as we got closer to the, but did the sparkling go away, the crazy sparkling? Okay, let's watch that go around again. Watch these pixels. You'll notice that these start to become, you start picking the lower resolution image. It's really pixelated. You can tell the pixelation as it gets closer to being to the edge. Okay, but at the benefit though is that, hey, now our thing went away. You know, our problems went away. Now let's go back to the Godzilla image, because the Godzilla image is low resolution, and we had the opposite problem. What was the problem with the Godzilla image? The resolution was too small. Okay, and you'll even see this on the MIP mapping. Okay, it's a lower resolution texture. But our problem was when we kind of magnified it, right? We have the big pixelated blocks, you know, and that was kind of, people are used to that in the early 90s, but then as hardware came out, there's ways of filtering this. So watch the Godzilla image, you'll see that it gets really, really pixelated. They're like, whoa, I just lost all my detail there. Okay, so here's how we fix that. For one, let me go to the rectangle object again, and we're going to change all the texture coordinates because we already saw the repeat. Okay, so going back to the Godzilla image, you'll see over here, right? We're back to our huge pixels. So let's fix that. Or let's just attempt to say, hey, maybe instead of maybe what we could do is kind of smoothly go from one pixel to the next. Instead of just saying on off, let's smoothly go from one value to the next. So in order to do that, we can change the magnification mode to linear filtering. So nearest means just pick the closest pixel. Linear means pick the two texels. That's what we call a pixel and a texture, a texel. Pick the two nearest texels and then blend the two based on my texture coordinates. So let's take our mag filter and apply linear instead of nearest. And now let's see what happens. Now we notice that the Godzilla texture map is like smoothly blended. Now this has the effect of blurring the texture map, but sometimes blurring something is better than just having it jagged, right? You know, it's a little bit more pleasing to the eye if this is the case. Now you will notice though, even though we have MIP mapping turned on, that as we go closer here, you notice how you can see the MIP map levels show up? And it's like, wait a minute. I thought we were trying to fix the pixelation issue by picking, we wanted to blend those. Okay, so let's go over here. And the reason why is because we said that when we're minifying the image, we're going to use a nearest filter. So let's pick linear, and we'll still use MIP nearest. Maybe we hit refresh on this so it starts on the edge. So now you can see that when we're applying the linear filter, even if we are kind of further back. Okay, so we're kind of being uniform here, where we're saying let's do linear filtering for the entire image, but we can still use MIP mapping for the texture when it gets further away, and that gets rid of the sparkliness that we are used to seeing. So let's see what happens over here. So yep, looks good. You can still see when the MIP map level changes, but it's still better, right? The image quality has improved. Okay, so that's called bilinear filtering, where you basically just say let it pick the MIP map level and then still use linear. But we're going to look at trilinear filtering. And what trilinear filtering says is not only will we smoothly go between the pixels, but let's smoothly go between the different levels of the map as well. So you notice as we get to the, as it comes back around, you'll notice that you can't tell when it changes, when the MIP levels change. Okay, so it's going around, and we'll see over here that this is really just about as smooth as you can get. Did you notice you couldn't really tell when it decided to change? Okay. There is one more trick up our sleeves. I'll probably have to talk about that next week. It's called anisotropic filtering, which is really, it's even better. It's like the best. Okay, I don't think we have time for that right now. Let's go look at the MIP map or the render to texture. Okay, so I can actually turn that on, I think, over here. Yay! Okay, so over here I am rendering this image to a separate buffer. So the Mitsuba object is there, and we're texture mapping the Mitsuba object. So this image, I'm rendering the full screen quad, but before I did that, I rendered to the texture map. Okay, so let's quickly look at that before we have to go. So over here, right, we have the G buffer, and we say we're going to write to the FBO G buffer. So I just named it what I think is good. And so whenever we use this render configuration, it's going to set that FBO up for writing to, and anything we draw will be written to that frame buffer. Then the next one is called R2T, so render to texture, and we're going to use this one to read from that texture map that we just wrote to. So over here, you'll see that the first part is that we're rendering to the G buffer, okay, and this is just rendering the Mitsuba object right in the middle. Then on the bottom over here, when we're rendering to texture, we're rendering the full screen quad, but this time the G buffer is being used as a texture map. Okay, and so inside the fragment shader, I have the G buffer color depth, the color attachment, the depth buffer, a flag that says whether we're using it, and the resolution of the G buffer in case we need it. And so over here, you'll see that I'm reading from the texture map for the just whatever. I was testing out whether we can read from a texture and also from the G buffer. So over here, the G buffer, we're reading that color in, and then we can just go ahead and use it however we'd like. Okay. So just as our closing thought here is, well, what if we were kind of talking about what happens if we make the what if we wanted that to be like a screen inside the, so let's see if we do this. Turns out we can break it pretty easily. Let's just rotate it along the y-axis. Or not. Let's just go back to this. Okay. Anyways, the main point is that we can render it to a texture map and then use those. So if the G buffer is rendering out like normals or whatever, then we could use that then do the lighting calculation later on instead of it really broke. Oh, that's right. I forgot to press space. This is just user operator error. Okay. It's not acting 100% the way I want, but that's funny. Can anybody, I guess if you, can you tell me why that happened? That's, that has to do with, okay, if I do this, I'm going to draw the rectangle instead of the full screen quad. The reason why I do that is because the full screen quad is oh, okay. Anybody tell me why that's happening?
Is it Z fighting?
The Z buffer is fighting the Z buffer because we're trying to draw them at the same location. I can just do this. Okay. Any questions on render to texture, texture maps? Yeah, there we go. So if we wanted to have a screen somewhere inside of our, if we want to have a screen somewhere, like pretend we're simulating a computer monitor, you know, inside a 3D graphics scene, we can render to texture. Sometimes this is used for rendering things like faces, like look at the Lego movie. Like all the faces are actually technically rendered to a texture map, and then they use those rendered texture maps for the facial expressions. Okay, and then yeah, next week we'll come around, but if you can get some maybe next week, think about why this image now is backwards. Okay, so think about that question for next week. We'll ask that question. We'll start out with that.